Greetings and welcome. My name is Aaron Craig with Beyond Us Games, and what I want to do in this video is fix one problem with our animated object Sarah that we created from how to import and animate sprites, and also set up how to do better collisions. That way I can show you how to do that, because with the current system it's just not very feasible, and it'd be a big waste of time if we tried to incorporate what we have right now into setting up perfect collisions. So this is the project from how to import and animate sprites, but if you have any object that is animated and walking around, you're perfectly fine. So right now we have it set up with checking the keyboard for each one, and when we hold shift we can run and do all of that good stuff. But there's a couple of problems. The first one is that we're checking to see down here if we are just checking no key and then we stop animating. But that is not great, because if we move and then we just hold down a key like K, we will continue to animate, and that's a problem. Same thing for shift. If we hold down shift, we're supposed to run, but then if we let go of shift, we're still running. So we're not actually checking to see if we're still holding it down, we're still moving like that, and we don't want that. So what we're going to do is set up a different input system than this, one that is a little more clever, uses some very simple math, and will allow us to then do perfect collisions very easily. This input system was inspired by Heartbeast and Sean Spalding. I'm taking it and I'm going to explain it in my way and show you what I think the best way to implement it is. So I'm going to go ahead and delete all of this. And what we're going to do is create a couple of variables inside of the step event. So we're going to be checking the keyboard checks, and we're going to put those values into a variable. So we're going to go ahead and create a variable called write, and call it, and set it to keyboard check ord d. And what I want to do is actually just copy and paste this 4 more times. And we're going to change the names over here first. So we're going to go left, down, up, and run. And we'll change these accordingly. So left becomes A, down becomes S, up becomes W, and run we actually change completely to VK shift. So with that, these variables are always being the value of the keyboard check for that specific key. The reason that it needs to be inside of the step event is because those values will be changing all of the time, and if it's in the create event, it wouldn't be changing. It would be set only one time, and that wouldn't work. So the value of when a key is checked is 1, and when it's not, it's 0. And we're going to use that because Booleans inside of GameMaker Studio, the things called true or false that we use, they're actually numerically represented as a 1 and a 0. 1 being true, 0 being false. And we can use that information to do really simple math, but will allow us to do some very clever things. So we're going to make 2 more variables here. We're going to call it hmove, and we're going to call it vmove. So horizontal move and vertical movement. Okay. So hmove, we want to be moving across the x-plane. So how we're going to do that is by checking our right and our left. And we're going to put this inside of parentheses and just do a simple subtraction. We're going to say right subtract left times walk speed. So right minus left. Let's take a look at this. Right, if right is being held down, that means D is being pressed, then it will be 1. And if left is not being pressed, it will be 1 minus 0, which is 1. Okay, great. Now if left is being pressed, it's going to be 0 minus 1, which is actually going to be negative 1. And that's great too, because when we move left, we're actually moving, well, we're moving left. And you remember, going left, you actually need to do subtract from the x to move left, because the origin is 0, 0 in the top left corner. So anytime we move away from the origin, we need to add to the x or y. Anytime we get closer, we need to subtract x or y. So that actually works perfectly. So this will be -1 when we're going left, and it will be +1 when we're going right. And we can multiply that by walk speed, and then it's going to be either 3.5, because that's what walk speed is normally, or it will be -3.5. And then we can come down here and just say x plus equals h move. So it will always move in the correct direction. And if both of them are held down, it will be 0, and so the player will just stop moving. So we're going to do the same thing for v move. So we want to say down minus up times walk speed. And again, down, because down going down is increasing from x, or from y, from the origin here, and going up would be decreasing. So if we add y plus equal v move, we can actually start moving right then and there. That's all that we need to be able to do that. We're not animated, we're not changing our sprites or anything, but you can see here that we're moving, and if you hold both, you'll just stop moving completely, either way. So that actually works really well. And this is important because we need to have individual move speeds, individual variables for going vertically and horizontally, because when we start doing collision checks, we need to actually be checking to see if we're going left or right, up or down. That way we can decrease the amount of code that we need to do by a significant amount. And putting the X and the Y movement into their own lines of code here instead of inside of the if statements like we had before will allow us to do some very important things that we'll get to in another video. But just know that having these here actually frees you up quite a bit, because now we can change walk speed, we can change these things, and we can check them, but we're not actually moving until all the way down here. So that allows us to do a couple things. So let's get our animation set up correctly now. And to do this, it's just going to be a bunch of if statements like we had before, but they'll be a lot easier to read now. So we can actually say if right sprite index equals SPR Sarah walk right. And you can imagine that now we're going to do the same thing for the rest of them, because we're actually going to change the animation speed in a different if statement, because we don't need to worry about that inside of here. So these ones don't have a lot of repeated code, which is always a good thing. So if we're going up, change it to walk up, and if we're going down, change it to down. Okay, so that takes care of all of the animation right there. It changes all of the sprites. Now we just need to actually be changing the image speed itself. So to change the image speed, we can actually just say, are we moving at all? And we know if we're moving if H move and V move are not 0. Because if both of these are held down, these will be 1 minus 1, which is 0, times walk speed, which 0 times anything is 0, so it's not going to be moving. So if we are moving at all, we need to be setting our image speed. So we're going to say if H move doesn't equal 0, or V move doesn't equal 0, set image speed equal to what we were using before. Walk speed divided by 3. And we can say else right here. And then if we aren't moving, then we want to do the same thing that we had before. We'll set image speed equal to 0, because we don't want to be animated anymore. And we want to set the image index equal to 0, because it looks really nice if we set it back to that 0th index. So if we do that, we're actually almost completely done. We have almost all of the functionality that we had before, but now if I hold down K and I stop moving, we don't have that issue. The last thing to implement is just the running, which I imagine you can figure out because we've already done this with lots of these if statements. If we say if run, we'll set walk speed equals 7, and else walk speed gets put back to the normal value. And if we do that, that actually is everything that we had before, but now in a different system. So if I hold shift, I'll run, but if I let go of shift, I'll stop immediately. So that fixes the running and the holding a different key and keep animating issue. So that actually fixes both of those things that we wanted to fix, and it is actually just one more line of code than what we had before, but I also think it's much easier to read than what we had before as well. Plus, all of this is grouped together, which makes it so you can come in here and change this really easily, and you can see each section is just logically laid out for what we're checking, which I think is really important when you're coding as well, is to have your sections separated by what they do so that you can come and find them later on very easily. So that is a clever way of checking keyboard input, and this can be used for any kind of keyboard input that you want. You can put any other key inside of here, and if you have two keys that conflict, you can do the same kind of math that we had right here, and it will work perfectly. You can use the fact that Booleans are ones and zeros to your advantage when you're making your keyboard check and your keyboard inputs for your game. So that's what I've got for you now, but now we are all set up. So in the next video, I'm going to show you how to do perfect collisions for any top-down game. That includes RPGs, shooters, platformers, whatever. It'll be great. Thank you very much for joining me, and as always, have fun making great games, and I will talk to you later.